in class 12th, I am taking the pivoted galvanometer or Western galvanometer. In case of the suspended galvanometer, the large currents cannot be measured because when a small current is passed through the coil swings in the magnetic field for a large time, and it takes a very large time to come at rest. Also, the procedure of finding the current or the calculation of the current is the very typical one. So everyone cannot use that suspended coil galvanometer. So keeping in mind the defects of the suspended coil galvanometer, the pivoted or the Western galvanometer is used. The name Western is given because this galvanometer was manufactured by the Western company. So this is named the Western galvanometer. The calculation of current by suspended moving coil galvanometer is very complicated and typical. So it is very hard and more time consuming. The coil in suspended galvanometer swings for a long time and swings for a long time to come at rest. Second is the large currents cannot be measured by suspended coil galvanometer. So these are some defects keeping above points in mind, the improvement of suspended coil galvanometer was necessary. The suspended coil galvanometer was made deadbeat galvanometer by binding the coil on a conducting frame, तो क्या होता है जब कंडक्टिंग फ्रेम पर इसको बाइंड कर देती है तो जैसे ही कुंडली स्विंग करती है तो उसमें डैम्पिंग स्टार्ट हो जाती है, तो एडी करंट्स पैदा हो जाती है, उससे उसमें डैम्पिंग स्टार्ट हो जाती है, तो डैम्पिंग की वजह से डेड हीट हो जाता है ऑन ए कंडक्टिंग फ्रेम. The conducting frame provides damping, so coil comes at rest when passing currents through it becomes zero. तो जैसे ये करंट का मान जीरो हो जाता है वैसे ही तुरंत ये डेड हीट हो जाता है. और उसमें क्या होता था कि अगर उसमें करंट का मान जीरो कर दिया गया फिर भी कॉइल इसमें स्विंग करती रहेगी इस तरीके से, दैट विल स्विंग एंड दिस टेक्स ए वेरी लॉन्ग टाइम टू कम एट रेस्ट. बिकॉज ऑफ that galvanometer is not more usable. So this is make the dead heat by binding the coil on the conducting frame. The coil is suspended between two wires. So it is called the pivot galvanometer. So it is called These galvanometers were manufactured by Western Company. Western Company. So they were named Western Galvanometer. Named Western Galvanometer. So this is what the nomenclature of this galvanometer. Now that we are having this a conducting frame, this is the conducting frame. This is soft iron core. And these are the wires on which they are constructed. This is now like this. This is the coil, this is the frame, and here we are having the magnetic pole pieces. This is now north, this is now south, and this we are having spring. Like this. This is now pivot like this one. This is pivot, and these are the terminals. T1 and T2. This is now pivot. This is now also pivot. Pivot. This is now spring. This is also the spring. And this is the coil, and this is the frame. This is frame, conducting frame. More better is conducting frame. conducting film. So this whole arrangement is made in a non-conducting box. Now the arrangement shown here is a galvanometer that shows the indication. This is a scale 0, this is now 0, this is now your 1, 2, 3, 4, 5, 6, 7, 8, like that. This is now scale. And this is a pointer. Here we have this pointer. The arrangement shown here, I can have no space to here, but this is now pointer. Aluminium pointer. The arrangement shown is made in a non-conducting box. Provided with a glass window to see the deflection of pointer on the scale. Now this galvanometer is used for to find the direction of the current or to detect the current in the circuit. Uses: number 1, to detect the current in circuit. Current in circuit. And second, to find the direction of current. To find the direction of current and to make ammeter and voltmeter. So these are the uses of this WESTON galvanometer, that we can find the direction of the current in the circuit, and also we can find that whether there is a current in the circuit or not. And second thing, the last one is that we can convert this into galvanometer and into ammeter and that of the voltmeter. So this is about the pivoted galvanometer and the WESTON galvanometer. So thank you very much.